Hello everyone. In this particular video, we will be introducing recursion. Now, what is recursion? Suppose you are given a function. The prerequisite of understanding recursion is understanding function and memory management. What is function? Function is a block of code which you can use to write some piece of code in between them. It makes your code more readable. Here we can see a function fn has been defined in Python, and it has some piece of code written in front of it. Now, what is recursion? Let's take a small example to understand recursion here. Let's say I create three different functions. All three of them are intercalling each other. Like function one is calling function two, function two is calling function three. Now, what we are gonna do? We are just printing numbers in them. Suppose if I have to print 100 numbers like this, I will have to write 100 different functions, all of them doing the same work. What is the work they are doing? Printing numbers. Function 1 is printing 1, function 2 is printing 2, function 3 is printing 3, and so on up to function 100. It will print 100. Let's say I want to print 10,000 numbers, then I will need to write 10,000 functions by my own hands. This will be a very tedious task. Instead of writing multiple functions doing same kind of work, I can create one function, repeatedly call it multiple times with different values. So same piece of code will keep running again and again and again for different values of parameters. This is what we call recursion, that we repeatedly call the same function again and again and again with different values so that our work is done until our solution is achieved. Now, in order to understand recursion, I will use a classic example of Fibonacci numbers. What is a Fibonacci? Fibonacci is a series in which the seed values, the first two values are 0 and 1, and the remaining values are sum of the preceding two numbers. So the third number is the sum of second and the first number. Second number is sum of the first and the zeroth number, and so on. Now, what we are going to do here is this. We will try to calculate Fibonacci using recursion. As mentioned, the current Fibonacci is the sum of the last and the second last Fibonacci number. So what my thinking will be, since the current function call calculates the nth Fibonacci number, I will call the for the n minus 1th Fibonacci and n minus 2th Fibonacci using that same function. Recursively, that will work for me. Since you guys are in class 12th, there is a concept of principle of mathematical induction. I'm sure you guys have heard that for a p of k, you assume for any random value n of k equal to true. It works. And using that particular example, you calculate n is equal to k plus 1. Same thing is going to happen here. That what we do, we assume that n minus 1 will work irrespective, and same Fibonacci of n minus 2. When n minus 2 is passed in that function, that will also work irrespective. Now let's understand how this will actually work. So here is a visualizer called recursion.vercel app. We will visualize this piece of code to understand this piece of concept. As you can see, the code works from top to bottom hierarchy. So for every function, a is equal to f of n minus 1 will run first. Once this line is over, then only f of n minus 2 will run. So if I say this is line 1, this is line 2, line 3, line 4, and line 5, then for every function, line 4 will occur first before line 5 starts executing. Let's run that. So when you run this piece of code, a particular tree will oscillates in front of us. How is this working? Let's try to understand in smaller way. So L5, if n with n, well, n is 5, starts running. So it start is n 0? No. N is 1? No. So a is equal to f of n minus 1. What is n? N is 5. So 5 minus 1 will be 4. Fn5 calls Fn4. Now same way. Now n is filled with 4. Is n 0 or 1? No. So a is equal to f of n minus 1. 4 minus 1, that is 3. And this keeps on happening. 3 will call 2. 2 will call 1. And the moment we reach 1, n is equal to 1 is already there. So we return n. Now, this particular variable n is filled with 1. Since n and 1, these are same basically, we will return n. So n is filled with 1, we will return 1. So as you can see, this particular functions return back 1. Fn2 continues start running. So this line is over for n equal to 2. Now this line will execute for n equal to 2. From every point, two functions are called. Both the lines are over for n equal to 2. Both the lines are over for n equal to 2. Now we will run the third line, which is a plus b. A is 1, b is 0, 1 plus 0 will be 1, we return back 1. So for n equal to 3, f of n minus 1, which is this line, is over. Now the second line for n equal to 3 will execute. Now both the lines for n equal to 3 is over. We execute the total and return back. Now for n equal to 4, the line with value a is equal to f of n minus 1, that is over. We will run the second line, which is f of n minus 2. You can see for every function, first n minus 1 executes. So that take example for n equal to 2. First n minus 1, that is 2 minus 1, that is 1. F of 1 executes. Once that is over, then f of 0 executes. So for f of 5, f of 4 is completely executed. Now f of 3 will be executed. And this keeps happening in a chain. You can recursively think that you called fn4 and that worked. It got you the fourth Fibonacci number. Then you same way you called fn3. It got you the third Fibonacci number. Assuming both the lines will work. Why will they work? Because same piece of code will keep running again and again and again for different values of n. Here n is passed as 4. Here n is passed as 3. How? 5 minus 1 will resolve itself to 4. And once it resolves itself to 4, that 4 will be filled here in the place of n. You got the last number and the second last number, you add them and it is over. So this was an introduction to recursion. That's it for this particular video. Take care. Bye bye. See you guys in the next video.